cosine of theta is greater than 0. That's the first thing they tell us for problem number 45 out of your textbook. Alright, cosine is greater than 0. And then what they tell us is that sine of theta is equal to negative 2 over 5. Okay? So then what we need to do is we need to figure out what tangent of theta is and secant of theta. So they want us to calculate what tangent of theta is and what secant of theta is. So the way that this works is, this is like our xy plane. Cosine is normally adjacent over the hypotenuse. But we have, your textbook calls it quadrangle, or I can't remember how they word it, but Mr. Adams learned the term reference angle. So what we do is we have 4 potential triangles that we could draw on the circle that'll give us the ratio of 2 to 5 for sine. So we need to remember that sine of theta equals opposite over the hypotenuse. So what they're saying is, if I draw a right triangle like this, there's some theta that has the opposite and hypotenuse and the adjacent such that I get a negative 2 over 5. So it could be a negative 2 over a positive 5, or it could be a positive 5 over a negative 2, or I'm sorry, the other way around. The 2 could be negative, or the 5 could be negative, but not both. Does that make sense? So what that means is my angle theta, I could have a reference angle there, I could have a reference angle there, a reference angle there, and a reference angle there. So there's 4 potential triangles that I can use that all have the same angle for theta, right? Here's theta right here, and here's a theta here, and here's a theta here, and here's a theta here. So for this problem, we don't really care what theta is, we just want to know what the points are. So if I were to do this problem without knowing which triangle it is, it would be easy. I would say sine of theta is equal to negative 2 over 5. And for the time being, I'll ignore the 2 over 5 business, or the negative part. If we just kind of ignore that, we know that sine of theta is really the opposite over the hypotenuse, which means that the hypotenuse is equal to 5, and the opposite of theta is equal to 2. And we'll just ignore the negative for now. How do I find the adjacent? Pythagorean identity, or Pythagorean theorem. Except we write it a little different. We say the opposite plus the adjacent squared is equal to the hypotenuse squared. Okay? Well, the opposite is 2. I don't know what the adjacent is yet. And the hypotenuse is 5. So I've got a squared is equal to 5 squared minus 4 squared. Or 25 minus 16, or a squared equals 9, which means that a equals 3. Is that right? Oh wait, it's not 4 squared. It's I made a little mistake here. I got a little bit ahead of myself. This is actually 5 squared is 25 minus 4, right? Because it'd be 2 squared, so that would be 16. No, it's not 16. What is it, 19?
21.
21, I'm sorry. I'm really having a rough day with this today.
I think we should just stop.
No, stop. So this is 21, so then A is equal to the square root of 21. All right. I got it right eventually. Let me double check that and make sure. 25 minus 4 is 21, yeah, square root of 21. So what they wanted us to find was tangent and cotangent. Or not cotangent, it was a tangent and secant. So if that's the case, once I have my triangles drawn, I would say that tangent of theta is equal to the opposite over the adjacent, and secant, what was secant the reciprocal of? Who can tell me off the top of their head? Cosine. So if cosine is the adjacent over hypotenuse, what's this one? Hypotenuse over adjacent, good. So I just plug in the numbers. So this would be like 2 over the square root of 21, which if we rationalize the denominator would be 2 root 21 over 21. And then this one would be 5 over the square root of 21, which would be 5 times the square root of 21 over 21. The problem is, I did that whole problem and I don't know which one's negative. In other words, is the hypotenuse negative or is the opposite negative? Either the 2 or the 5 have to be negative. So now we gotta go back and look at this unit circle. So I'm almost done. They give us a clue. Cosine is positive. Sine is negative. One of the quadrants, cosine is positive, but sine is negative. Then once I figure out what quadrant that exists in, that's how I'll know what the triangle is. So here's what we're doing. We said that the opposite was, what was the number? 2. What was the hypotenuse?
4.
And what did we say the adjacent was?
Square root.
Square root of 21. So this point right here is the point square root of 21, comma, 2, isn't it? Because I go over the square root of 21 and then go up 2 to get to that point.
Yeah.
What's this point over here? Negative square root of 21, comma 2. This one here would be what? Negative 21, negative root 21,
Negative 2.
negative 2. And then lastly, this point here,
21.
square root of 21, comma,
Negative 2.
negative 2. So now we do things a little different. We're used to seeing sine of theta as equaling the opposite over the hypotenuse, but on the unit circle, the opposite is really the y value, isn't it? And the hypotenuse is really the radius of the circle, isn't it? Does that make sense? So then cosine, which is the adjacent over the hypotenuse, is really x over the radius. Take a second and look at the board. Let it soak in. Does that make sense to you guys? All right. So cosine is positive, so that occurs when, oh, here's one more thing. What is the radius of the circle? Is that ever negative? No. The radius of the circle is never negative. So when I say the cosine is positive, what am I really saying? X is positive. So it can't be these two quadrants, right? Because the x's were negative. Does that make sense? Now we got to come over here. When I see that sine is negative, what am I really saying? y is negative. So it can't be this quadrant. So what do you know?
It's the square root.
This is the quadrant 4. So we're looking for the reference angle that lives in quadrant 4, which we have x comma y. Now here's the interesting thing. I'm going to make a little room here. Tangent of theta is the opposite over the adjacent, but isn't that really y over x? It's technically y over r over x over r, but the r's cancel, so you end up with y over x. Well, what is the y value? -2. What's the x value? Square root of 21. When you rationalize the denominator, you get tangent of theta is -2 times the square root of 21 all over 21. Okay. Now for secant. Secant is the reciprocal of which trig function? Cosine. Cosine is technically x over r, so secant would be r over x, which is, what was the radius again? 5. What's the x value? Square root of 21. So it's 5 root 21 over 21. Which is almost what we had before. What's the only difference? The only difference is, when we did it the other way, we forgot about that negative sign. Well, we didn't know about that negative sign. What's the answer in the back of the book say? This stuff, right? Double check real quick, because Mr. Adams doesn't have his answer book here in front of me. 45. While they're double checking, does anybody have any questions about what I did? It took me a long time because I wrote it all out, but once you get familiar with this, it's real easy. You sketch the circle, you figure out what quadrant it lives in, and then once you know what quadrant it lives in, you use the Pythagorean identity to solve. I see some hands up. Yes?
It just says that it didn't rationalize whatever you said. It has it as the -2 over the square root of 21.
Okay. Yeah. Well, Mr. Adams wants you to rationalize it. But it's right? The -2, right? Yeah. What's your question?
Well, I was wondering how you rationalize.
I'll do that in a second. Any other questions? Was yours how to rationalize?
Yeah.
Okay. So, I kind of ran out of room. Let's review this. How to rationalize if I have 3 over the square root of 5, we don't like to have square roots on the bottom of a fraction. So one way to get rid of a square root is to multiply it by itself, to square it. So if I multiply this by the square root of 5, remember with fractions, whatever you do on one side, you do on the other. Now what's square root of 5 over the square root of 5? 1. Anything times 1 is what? Itself, right? So this is an equivalency. However, when I multiply the bottom, I get the square root of 5 times the square root of 5, and on the top I get 3 square root of 5. Well, the reason it gets rid of the square root is that I'm literally squaring a square root. So what happens when you square a square root? What are you left with? Just the base, right? Just the base. So Mr. Adams was kind of cutting out all this stuff, and I was saying that 3 square root of 5 is the same as 3 root 5 over 5, right?